Algebra 1, this is 8.9. We're going to talk about perfect square trinomials. And so to start this off, guys, we're going to actually have to square this. Square x minus 2 squared. Because today we're not multiplying, we are going to factor. We're going to actually create this x minus 2 squared, but I want to show you guys what it'll look like at the end. And I do believe we had a lesson like this where we had to multiply these out using the patterns, right? Either way, we're going to do it again. I think everybody should agree that x minus 2 squared is x minus 2 times x minus 2. And if I bring out the four-letter F word and FOIL this, x times x is x squared. X times negative 2 is negative 2x. Actually, let me retract this a little bit. I'll start with the plus 1. Okay? Make it a little easier. Just put a little pluses there. So x times 2 is 2x. And I go to the 2. That's 2 times x, which is, again, 2x. And 2 times 2 is 4. What do we notice about the middles again? They're the same. So you get x squared plus 4x plus 4. Because there's always 2 of the middles. Yes? Now, let's take a look here. What we're going to do today is we're going to be given this, the trinomial, and we are going to identify that, whoops, not that line. We can identify all the way back to here. I'm going to be able to factor it in one step. Well, maybe 2. Okay? This is how I'm going to do it. So let's do factoring perfect square trinomials. Let's give some steps here. Number 1. Write down pattern. Mr. Contract, what's the pattern? You didn't give that to us yet. Well, the patterns are something squared plus 2 times something something plus something squared. Notice that kind of, because it looks like the AX, or the expanded form, which is here, where I have x squared, I have 4x, which will be made up here, and then the last term of something squared to get 4. Okay. 2. Find the ends first. Basically, like we did the difference of squares, you look at the end numbers. Is the end number a perfect square? Like x squared, is that a perfect square? Yes. You plug that number in. Is the last number, like 4, a perfect square? And you would say, yeah, it is. Because here's the thing. Here's the pattern, guys. I'm going to put this in just like we did the difference of squares. That's an A, B, and B. Your whole idea again is to find A and B. So in step 3, once you found your ends, once A and B are found, move them in for multiply, or simplify, should I say simplify instead. Simplify the form. Very general. I want it to work for everyone that is a perfect square trinomial. Here's a trinomial. The question is it a perfect square trinomial? And if it is, I want you to factor it. Now, we could factor this the old school way, as in, hey, a is equal to 1. That's our leading term. So I can find the factors of 4. That'll give me 4. That'd be 2 and 2. And I can factor it that way. Or you recognize that, wait a minute, is the first term a perfect square? Is it a perfect square? X squared perfect square? Yes. Is 4 a perfect square? Yes. So therefore, does it fit the rest of the pattern? That's what we have to ask next. So I'm going to write it down. Can I make it fit that? And this is where steps 2 and 3 come into play. So I look at x squared. What's squared to give me x squared? X. Moving all the way to the end. What's squared gives me 4? 2. I am then going to take those values and move them in. X and 2. Check. So actually I might have to go back and fix my steps. I was going the other way. Check. Does this equal that? Does 2 times x times 2 equal to 4x? Yes. Therefore, it is the first and the last number added together squared. Done. Factored. Okay, so what I did was I took out the step number 4 about multiply, because we're not multiplying, we're not trying to create the perfect square trinomial, we're going the other way. You need to check those middles like we just did in that last problem. Does the 2 times a times b equal the middle term? And if so, then you may write it in the factored form of a plus b squared. And you're done. Next problem. Is this a perfect square trinomial? And if it is, factor it, please. 4y squared plus 12y plus 9. So let's check it. Is 4y squared a perfect square?
Yes.
Yeah.
Is 9 a perfect square?
Yeah.
Okay, so this is promising this could work out. So what I'm going to do is create the pattern that I will use to check. Now remember, the outsides move in once we find them. So what's being squared to give me 4y squared?
2y.
It's a 2y. And what's being squared to get 9?
3.
A 3. And then all we do is move them in. 2y and 3. We know the ends are going to work because you square a perfect or square a number, it gets that perfect square that we created or got it from. The middle just needs to check out. Is 2 times 2y times 3 equal to 12y? And the answer is
Yes.
yes. Therefore, it's a perfect square trinomial. Which means when I go to factor it, it's just the ends pushed together. Which is 2y plus 3 squared. Done. I like it. Try the same thing here. Tell me if this is a perfect square trinomial or not. Here we go. 9x squared. What would it have to be? 3. X. 4 would have to be a 2. Moving them in. 3x and 2. Does 2 times 3x times 2 equal a negative 6?
Yeah. No.
No. So therefore, not a perfect square trinomial. Okay, so then that's all you have to do for that. Now, I'm just going to give you guys a friendly reminder that our equations could be set equal to 0, yes? Which means when I factor it, it's set equal to 0. What's the quickest way to solve when two things are multiplied to equal 0? Set them both equal to 0. Wait a minute. There is 2 terms of 2y plus 3 here. But can't I just square root both sides first? And the square root of 0 is still just... So when does 2y plus 3 equals 0? Guys, perfect square trinomials end up having two answers, but both of their answers are the same. So in this case, I subtract 3, so 2y equals negative 3, and I divide by 2, so y equals a negative 3 halves, or negative 1.5. It's used twice. That's why there is a square on it. Two of them at negative 1.5. So let's talk about that list again. Factoring list. First thing you should always do, greatest common factor. Greatest common factor is always the first thing you should do. Is there anything in all of them that they can give up? 2. If it's got two terms, think of difference of squares. If it's got 3 terms, do factoring of trinomial. Let's see. Oops, wrong way. Wrong way. Let's just do factors. Oh, sorry, right? Put 3 terms first. If there are 3 terms, then we have to do factors of C or the factors of A times C, and then do factor by grouping, right? Fourth one, what happens if there are 4 terms? That's where you do factor by grouping. Factor by grouping. And 5, actually, I'm going to back up here. We can add 1 to the 3. Look for perfect squares. Perfect square trinomials. So that's kind of your list of things. We actually have another one for 2 terms, which we're not getting to right now. It's called the difference in sum of cubes. So we won't do that. We're skipping over that one. But this is kind of your general list. Always look for common terms. If there's 2 terms, think of difference of squares. If there's 3 terms, you got 3 options. Technically, the perfect square trinomial at the end here can be rolled into these 2. So you don't have to remember that, but it makes it go a lot quicker. And then if there's 4 terms, you factor by grouping. And the last thing I want to talk about is square root. If I had you guys solve x squared equals 25, how do I solve that? What do I do with both sides to get rid of a square?
Divide.
Not divide, but take the square root. Here's the thing. When you square root solving an equation, you need to have this in front of this other side. Plus or minus. Because x is equal to plus or minus 5. If I just ask you what's the square root of 25, you just say 5. But if I ask you that to solve x squared equals 25, it's because 5 times 5 is 25, and negative 5 times negative 5 is also a positive 25. So be careful for that.